Hey guys, oh god, it's thundering outside. Damn. Anyway, so this video is just gonna be kind of like a video log or a vlog, whatever you call it. I mean, it could be kind of like a tutorial, but it's gonna be really long because I'm actively trying to figure this out as I record. But I was messing around with recently I posted a video of me messing around with NASA assembly, just messing around with it and like using it in a virtual machine to make kind of makeshift operating system. I've been like watching videos online on how to do it. Like I wouldn't be able to. I used to think that it was magic, but now I know you just need you just need a file that can be read by the BIOS or the read by the motherboard in the hard drive. It's just it's pretty simple. But anyway, the point of this, the point of that whole that information is that I was doing it, and I realized, at some point I'm gonna want to be able to print numbers that are in a register. But it's not as easy. I mean, as it might sound immediately, because this is assembly. We don't have any libraries or anything, since it's since it's an operating system from scratch, we're not going to have any libraries to use, so we're going to have to do this ourselves. So anyway, I decided, I think it would be a lot easier to kind of test that the formulas out in C++ first. So I went and did that. But anyway, I remembered that there's this thing called a modulus in C++ and C. It's just a percent sign, but basically it gives you the remainder of division between two numbers. So let's see. Let's get like the biggest number that we can get in with 32 32 byte, or no, not 32 byte, 32-bit integer. And that it happens to be 4,294,967,295. It's a pretty wacky number, but that's the number that a 32-bit integer can hold. But anyway, so let's define that. Let's call it x, and make this that. And now I already tried something before the recording. I tried doing the modulus, and decimal numbers are base 10, and what that means is that they have 10 possibilities for each digit. So like there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 total possibilities, and then once you go past that, you carry a number onto the next digit. But anyway, I was trying to do the modulus of x and 10, because decimals are the decimal number system is a base 10 number system. So let's do standard cout x modulus 10, and whenever I ran it, at first I was kind of disappointed because wait, what the hell? That's not. Oh, I forgot to put unsigned. That's why. Okay, at first I was disappointed because it wasn't the number I was expecting. But then I realized, actually, the last number happens to be 5. So I decided, what, maybe this is actually gonna work. And I was remembering I did have a thing where I converted hex strings or integers to hex strings for debug, kind of like a debug thing to see what the hex number of addresses. It was like it was just like for like yeah, what do you call it? It was just a hobby thing. But anyway, I remembered that I did a very similar thing with that. But what we can do is I think so. What we can do is if we make another variable. This is and this isn't going to be how it's going to be done like in the actual function at the end of this video. Like this is very unoptimized. Like there's no reason why I should be making multiple variables. But just for now, just to show like show my point, like get my point across. Let's make a variable called y, and then we're going to make it x divided by 10. And as stated before, modulus just gives the remainder of two variables divided. So if we do an integer divide of x divided by 10, and then we go down here and we paste the modulus of y by and 10, you'll notice that it is 9, and it's 9 here. So, and then if we do it again, if we do do the same thing again, if we do z z modulus 10, you'll see that it is in fact 2, and that's 2 there. So we've already got a method of actually calculating the decimal characters of the number, but the problem is that it's backwards. So we're gonna have to in assembly we're gonna have to make an array. We're gonna have to make or not an array. We're gonna have to make kind of like a character buffer where we can write the results to like a string, and then after we're done, we can like go through that. We can iterate through that string backwards and print the number correctly. And then this is just gonna be for signed numbers. Or not signed numbers. This is gonna be for unsigned numbers. Signed numbers are gonna be a whole different thing. But anyway, with that knowledge that we have now, we can actually go to assembly and start making our function. But anyway, so right here, okay, we've just got a basic. This right here, this is what I was working on one of the last videos. I just made it so that it copies all the text you paste and then pastes it. But anyway, so we can use this type buffer here to actually put the numbers. So if you don't know, if you're not an assembly programmer, there's a function or an instruction called div. It divides, and it actually quite conveniently does exactly what we need in this situation, because it puts the result of the division into EAX, and then it puts the remainder into EDX if you're doing 32-bit divide, or if it's like 16-bit divide, it'll put the result in AX and the result in DX, or not the result, the remainder. You know what I'm saying? You know what I'm saying. But anyway, here we've got. I wrote some notes. I've got result is EAX, remainder is EDX. So since we're going to be using both of those, we're gonna want to clear the, or we're gonna want to push them and then pop them after the function, just so that we can keep their value. But anyway, let's put print int. Well, actually, let's do PrintUnsignedInt just so that it's like accurate. But anyway, okay, so we're gonna want to pass the number that we want to print in EAX. So let's just specify that so I don't forget, because my memory is horrible. EAX is the number. Okay. So we're just gonna keep I think the way it works is we're just going to keep doing it until the result is 0, and then that's where we end. So let's make a loop. Okay, let's make a loop. And okay, so actually, okay, first we're gonna make the return just so that we don't forget. And let's push EBX. Yeah, let's push EBX. We're probably gonna need a lot of registers for this. Push ECX and push EDX, and then at the end we're gonna put pop EDX, pop ECX, pop EBX. There we go. Okay, so now let's get on to the actual meat of this function. So we're gonna pass in a 32-bit number, and that's going to be stored in EAX. So, actually, in fact, that's actually good, because that's how the divide actually works. So you put in, it's like a compound number that you put in both EAX and EDX. EDX comes first, and then it goes on to EAX. It's kind of hard to explain, but basically, just imagine that EDX has the numbers. Let's just imagine that EDX is the first numbers, and then it goes on to EAX, and they kind of make a whole register. They kind of like combine to make one register. Like it would be a 64-bit register if they were, if it was just one. But since we're in 32-bit, or since we only have 32-bit registers, because this is x86 assembly, we're gonna have to work with just that. And actually, you would have to work with that in x64 as well, because it still uses the same method for compatibility, backwards compatibility. But anyway, okay. So now we're gonna need to. Let me try and think about what we're gonna have to keep, or we're gonna have to like save. Okay, so first of all, we're just gonna have to put the loop head, because we're gonna need a loop. In fact, we're probably gonna need 2 loops in here. Let's just put a random number so it doesn't accidentally like. That's how I notate my loop head. My loop head jumps. I put a random number so that it can't. I can't accidentally go back to a previous one. But anyway, so you're gonna want to jump if not 0. We're gonna jump if not 0 to loop head, and we're gonna compare, or actually we're gonna add EAX 0, because the result is going to be stored in EAX after we do the division. And we only want to stop this loop once we've gotten the whole thing. And okay, you know what? I've got an idea. Okay, we can use the. In fact, it would be appropriate because ECX is the counter register, so we could use ECX to increment the memory position in the type buffer. So increment ECX. We're gonna put that there so I don't forget. So right here we're gonna move type buffer into ECX so that it now is the type buffer address is in the ECX register. So at each time we're gonna do we're gonna divide. Actually, wait. First, what we gotta do is we have to we gotta zero the EDX register. So because, like we said before, the EDX and EAX make a compound register whenever you divide. So anyway, let's see, what am I gonna do? Okay, alright, we're also gonna need another register, so let's push RDI, or not RDI, that's 64-bit, let's say EDI, push EDI, and let's pop that at the end, EDI, pop EDI, there we go. And the only reason we push and pop is just so that it saves the previous register values, so that we don't change it for people in the future that use this function. Like they won't have to change their registers back after they use the function, because it'll automatically do that in here. So yeah, it just pushes them on the stack and then puts them back at the end. All right, so int ECX. All right, we got that. Okay. So all right. So here is what we gotta do. We gotta move. Let's move 10 into EDI up here. Move 10 EDI, or no, EDI 10. All right, I forgot I was using AT&T syntax there. But anyway, so we're gonna. So the way it works is we're going to divide EDI, and then that is implied that it's going to use EAX and EDX, or at least I'm pretty sure. This is how the x64 assembly works, but we'll see if that's how it actually works here. And if it doesn't, it will know, because it won't work. Okay, so divide EDI, and then that will put at that point that will put the result in EAX and the remainder in EDX. So like we did with the modulus on a C++, what we're going to do is we're going to move the remainder. We're going to move EDX, or actually we're gonna move DL. Okay, actually no, wait, no, I just remembered. I'm forgetting something. We've also got to we have to take into account the fact that these are gonna be characters. So we're gonna, oh my god, it is thundering like hell outside. Okay, so we're gonna want to start at the decimal position of 48, and then we're going to add the value that is in ED, that is in ED, or not ED, it's going to be in EDX, yeah, or DL, it's going to be in DL. And okay, so we're going to, yeah, okay, we're going to move into, okay, we're going to move, and we're going to make sure that we're actually at this part. We're going to make sure we're actually at this part. And actually, you know what? We might actually need another register too. Push ESI, because we're going to need something to count how many times we looped through it. So pop ESI. Okay. And then ESI is going to be 0. XOR ESI, and then here we're gonna, since this isn't a register, this is the address number, it's not the actual thing. Or we could just, instead of having to increment 2, we could just put the original address in ESI, and then we can subtract ESI from the new address at the end, and that will give us the difference. So, and that will save us having to increment 2. So let's do. Okay, we've already moved the type buffer into ECX. So ESI, remove ESI, ECX, and yeah, and since we do that, we don't need to zero it anymore. Okay, yeah, this is getting really complicated, as you can tell. But anyway, like we said, like stated before, what we need to do is we need to offset the remainder by 48, and because that's where the characters are. So okay, so it's gonna be so divide EDI, and the remainder will be in EDX. So we're gonna move ECX, or we're gonna move the we're gonna move into the buffer, or the variable, move byte ECX, and we're gonna do, what are we gonna do? 48. Okay, 48 plus plus, what was it? Plus EDX, or no. 48 plus, since this is 40, since this is a byte, we're gonna put DL. So there, and that should be it. Okay, but let me just, in fact, let me just try and compile. Let's just compile this to see, make sure that I'm not doing some syntax error. Okay, yeah, okay, 68. Let's look at 68. Where's 68? All right, yeah. All right, yeah. I'm gonna have to. Okay, you know what? All right, I got a better idea. Let's just. In fact, let's actually put the zeroing of DX in here so that it always does it. But now, let's add DL, or let's add let's add DL 48, because that will offset it to the character position, and then we can move DL into there, and that hopefully will work correctly. Yep, it does. Okay, good. Alright, so that will and that will just keep going until it'll hopefully just keep going until EAX is 0, and then at that point it will have completed, or it will have done the whole string, because once the result is 0, that means we don't have any more numbers to divide or something. Maybe, I'm not, we'll see if it works at the end. But anyway, so okay, so jump not 0. So now that we've done that, now this loop is done. At least hopefully it's done. So we're gonna have another loop head, loop head, and then just blah blah blah, or just blah, 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 blah. There we go. That's my loop making noise. Whatever. Okay. So, and then we're gonna jump if okay, so we're gonna use ECX. Okay, we're gonna use ECX as the counter. So move, okay, move sub, okay, alright, sub, we're gonna do sub ECX ESI, and that will get the difference between the addresses, and it'll give the number, the amount that we went, the amount of distance we went into the buffer. Okay, and then so now that way we can jump. We can compare ECX 0 at the end, and jump loop head if it's not equal, or if it's not equal. Oh damn! I just pulled my freaking head. Oh no! Don't! Oh god! I just pulled my headphone wire out. I'm a moron. Oh my god! I'm a failure. I hate my life. I'm a failure. Everything sucks. Okay, I'm just kidding. Anyway, oh man, that made me forget what I was doing. Okay, so we jump if equal, or actually no, we jump if it's not equal to 0, because we don't want it to. We want it to only stop the loop once it's done. So, okay. So now so sub ECX will be, at this point ECX will be the number of that we have to do. So Okay, then we add. Okay. Then we add. Where's the there's the thing. We're gonna have to add the string to ECX. This is getting tricky. Okay. Or we could just okay. You know, okay. Or we could make it, we could compare it to see if it's the same as the test string, but I'm kind of worried that might have errors where it goes past it somehow. I don't know. Okay, you know what? Actually, we might not even need ESI because we could just decrement it until it's yeah. I mean, we could just decrement ECX until it's the same as test string. I guess, yeah. I guess we could do that. Add ECX. Okay. Move byte. Decrement. Okay, yeah. In fact, we're gonna. I think we're gonna do that. We're gonna do that. Okay, so decrement ECX, and then we will print. We'll print the character that's in ECX. So call PrintChar. Okay, so we gotta move into EAX. We gotta move the. In fact, you know, it can just be AL, or because it's gonna just it's gonna change it anyway. So we can just move AL, move the value that's in ECX, and then that will print it, and then compare if we just can compare and until it equals the original memory location. And in fact, you know, there might be a way to assembly jump if equal or below. Jump goes to, okay, I don't think there's a way that you can do. There's a way you can do jump if below, but I'm not sure if there's a way you can do jump if equal and below. Assembly JB based on the result. Okay. Jump JB. It doesn't say. Okay. Jump. Oh, okay. Wait. There might actually be a way. Okay. Jump above equal or jump. So it's. I think it's jump below equal. Jump below equal. Okay. Let's see. Jump below equal. Jump sort if not below. Where the hell did it go? Okay. Jump below equal. Jump sort if below or equal. Okay. Alright, okay, yeah, so we can use JBE. At least I think. Okay, let's see. Let's make sure it's in the NASM, because that's the compiler or the assembler we're using. NASM JBE. You know what? Okay, the easiest way to find out if it works or not is to just jump below equal. Okay, look. Oh wait. Oh shit. Wait. This is. Oh fuck. Jump below equal. Actually, no, that is right. Okay. No, wait, no, that isn't. Okay, we gotta... Alright, no. We jump if above. Okay, we jump if above. Alright, there we go. Now let's make sure that this actually works. Jump. Okay. I'm gonna save. Let's just make sure that it actually assembles. Okay, good. It does. Alright. So... You know, that might be it. And I think we might have done everything. I'm not sure, but we might have done everything. Because we move the remainder in there and just do it. Okay, alright, you know what? We're going to try this out. We're going to try this. Now, I am hoping to God that it works. Alright, you know what? Alright. Okay, move EAX. New line. Wait, no, actually, we already have a new line. Alright, yeah, let's do it after. Okay, new line. Call print string. And then call, or actually let's move EAX, and then we're gonna give some huge ass number like let's see, what can we do in 32-bit? Let's just do all that. Yeah, that's a good number. There you go, good number. Okay, so we're gonna move that into EAX, and then we're gonna call PrintUnsigned integer. Please work. Oh God, please work. Okay, disassemble. This is the moment of truth. Let's see. Hey, it worked. Look at that. Look at that. It worked. Although, I don't know what these are. Or that. What the hell? Oh, I know why. I forgot to zero terminate it. Okay. Okay, alright. Okay, now I see the problem. Okay. I forgot to zero terminate it. Although that still doesn't explain why it's doing variables that are before. Huh. Okay, yeah, alright, let's try. Okay, let's try putting a 0 at the end of this. Okay, so let's see, let's just, okay, let's, and it's gonna increment EAX, and then, okay, then we put, increment, or not increment, it's, wait a minute, actually, oh shit, wait, I don't know what is, because actually I just realized we're using PrintChar, we're not using print string, so there's no reason why it should still be doing that. Now, let me just check, and let's just see and make sure that it's not like something else first. Let's just get rid of those real quick and then run it. Okay, launch. Okay, yeah, it's not that. Or actually, no, it is that. It is not. It is this. It's just, I don't know what's causing all that other mess. I mean, I guess we can just put zero into this just for now, just to make. I mean, I'm pretty damn sure it's not gonna work, but I mean, we can try. It's probably still gonna be nothing, or it's probably still gonna be doing that gargled mess after launch. Yeah, I don't know why it's doing that. Huh. Okay, maybe I must be doing something wrong here. Okay. Let's see what happens if I put a bigger number. Where is my calculator? Okay. Okay. F. Okay, give me that number. That beautiful number right there. Hell yeah. Give me that. Okay. Okay, let's try with that number. Let's see how it does with that, because hell, it could mess up entirely. let's see. Okay, 429,496,7295. Yeah, no, it's doing the whole number. It's just, huh? Interesting. Very interesting. Yeah, I don't know why it's putting all that other shit. Okay, so it's after the, yeah, like it's I don't know why it's putting variables that are after this one. Yeah, maybe I'm not ending. Oh my god, I'm a moron. I put test string instead of type buffer. Oh my god. Okay, well that makes sense. Okay, now it should work perfectly. Alright, yeah. Fuck yeah, we did it. Hey, that's awesome, man. I didn't think we were gonna do it, but we did it, and I'm fucking happy. Hell yeah. Okay, you know what? Let's just put some other numbers. Let's put some other numbers. Let's see what else. What other kind of number we can do? Okay, let's see. Let's just do something like. Let's make it a hex number. So like AAAA. I don't know what the fuck AAAA means. So let's just see. What does it mean? What does AAAA mean? Okay. All right. Launch. It means 43,690. All right. Let's see if that's correct. Let's see. All right. Hex AAAA. And yeah, that's right. Okay, cool. Awesome. That's pretty damn cool. All right, we did it. We did it, guys. We did it. We made a registered to integer string function. Pretty damn cool. All right. Well, I hope you guys enjoyed this video. That ended on a much lighter note than I thought it would. Like, I thought it was just gonna be me messing around and failing for 3 hours straight, but apparently we did it. Okay, cool. Alright, well, see you guys. Thank you so much for watching. If you want to see more, just let me know in the comments, and yeah, goodbye.